Well, you shouldn't be. Alright. Day 12. The 12 days of tax review. Not tax review, STAAR review. Okay. So number 1. This is stop feeding me cookies. You're not feeding me cookies, children. The old lady's feeding me cookies. So this is going to be confusing. I'm not going to lie. The idea is we have one large custom that's 5 1/5 yards, and we have a smaller custom that requires 1/3 less. So ideally, this is a simple question of what is 5 1/5 minus 1/3.
Not hard.
And this is going to become difficult. I'd say on a real thing, I would just turn all this into decimals, turn all the answers into decimals, and don't mess with fractions. But since we're here, let's mess with fractions. First thing we need to realize is that 1/3 is bigger than 1/5. So if we try to take away 1/3 from 1/5, we can't do that. So the same way, side example here, we couldn't, if we had something like this. If you were trying to take 6 away from 15, you can't take 6 away from 5, so you have to borrow from here. You borrow from the tens place, and you add 10 ones to the ones place. And this is how we can subtract that. The same idea goes here. There is not enough in our fractional part to get this done, so we need to borrow from the whole number part. So we're going to borrow from 5. We're going to take 1 away from that, and that becomes 4. When we borrow from this, instead of taking 10 away, we take away one whole number. But we need to think of that as a fraction in terms of fifths. So how many fifths would it take to make a whole number? In this case, side example B, 1 whole is equal to 5 fifths. So we're going to add 5 fifths to 1/5. And we know that is just going to give us 6 fifths. So we're going to end up with 4 6/5 minus 1/3. And now we can subtract this. So we can actually start the problem now. We can consider how to make this work. I'm just going to rewrite it over here so I have some spot to work. Minus 1/3. Anytime we add or subtract fractions, remember we're looking for a common denominator. Hopefully we can recognize that a common denominator here would be 15. So we can say we have some number over 15, and actually it's going to be 4 and some number over 15. And on the bottom we're going to have a number over 15. So now we look, we say, how do we go from 5 to 15? Well, that's times 3. So we do times 3 up top. So 6 times 3 is 18. We do the same thing on the bottom. 3 times what is 15? That's 5. Thank you. So 1 times 5 is? 5. I'm just going to keep her here to say the number 5. And now we can subtract. We can take 18 away from
5.
And that gives us not 5, it's 13. And then on the bottom would be a 1 followed by
a 5.
A 5. For our whole number part, 4 minus 0 is
4.
Is 1 less than
5.
Which is 4. So how much, I don't even know what this is about, how much material is the smaller dress going to need? It's going to take 4 13/15 yards.
You can probably reduce that too.
You cannot reduce 13/15.
Oh yeah, I guess you can.
13 is a prime number. Okay, that's number 1. That took a while. Alright, number 2. This is Jose Vizcaino, in case you need to know. The reason why this picture is here is because the problem talks about Mr. Vizcaino, and I'm going to assume it's the same guy. He is famous. He shows up for the Yankees for 1 year and goes to the World Series and hits a walk-off home run in the World Series. So good for him. But now he teaches class and he has kids who show up tardy. And these kids have lame excuses. I'm going to make him tiny. So lame excuses. You need to say that, and you also need to say it while making air quotes. Lame, as in bad. He says that 66% of these excuses are lame, which I think the number is actually closer to like 99%. But what are you going to do? So 115 of his students were tardy yesterday. That's almost inexcusable. I'm not sure what his principal thinks about that. How many of their excuses were legitimate? So this is a percent problem. We can say, well, 66 were lame. We want to know how many were real. So we have to consider the difference here. So if 100% of the tardy kids, and we don't really care about the kids with bad excuses, so we take them away, and that'll give us how many, or what percent we really care about. So 100 minus 66 is 34%. So 34% of the kids had a legitimate reason for being late. So now this is just, a pretty basic proportion. We can say tardy, or actually this is legit tardy kids to total tardy kids. Set this up. We have 34% of the kids who are legitimately tardy out of 100% total. We know there are, this number makes me laugh, that there's 115 tardy kids. We want to know how many of those are legit. So we can cross multiply, and let's use our brain power to really work this one out. 115 times 34 is 3,910. We can divide that by 100. Oh, what the heck? Let's do that. I don't want to actually divide by 100, so I'm going to take my decimal place and I'm going to move it 2 places to the left so I can divide by the number 1. 2 places to the left here. 1 divided by 39.10 is 39.10. Since we can't have 0.10 of a student, no tenth of a kid running around, we can round this off and say that 39 students had a good excuse for being tardy. Let's give this guy the benefit of the doubt and say he has like 10,000 kids in his class. Alright, 39 students. That's it. I hope. I don't know, I'm trying to go through this quick. I want to go to bed. Alright, triangle. Has an area of 48 centimeters squared. Let's write that down. 48 cm squared. It has a height of 8 centimeters. What is the base? Question mark. So, we don't have any formula in our formula chart, our reference chart, that says what the base of a triangle is. But we do have a formula that talks about area and base of a triangle, and that's that area is 1/2 of the base times the height. And now we have most of this information. We know the area is 48. We know that 1/2 is 1/2. We don't know what the base is, that's just b. But we do know that the height is
8.
8. Let's space that out a little. So 8. So we have 1/2 of some number times 8 equals 48. So we can do some of this math here. We can take half of 8. Half of 8 is
4.
4. So we have 4 times some number, which equals 48. And if it doesn't occur to you what that number might be, we can work backwards and say 48
Divided by 4.
divided by 4, which will give us 1. Subtract.
12.
Bring down. Don't get ahead of me. Thinking you're smart.
I am.
You are.
Yeah.
Okay. She says she's smart.
Shut up!
Which she is, obviously. Where was I? This is 12 centimeters. So what is the base of our triangle? 12 centimeters. Thank you. Alright, here's where we get to the part where it's funny. Number 4. Find the area of the base of a laptop which measures 11.5 inches by 14 inches.
So you use a toddler laptop?
I figured I would use a picture of the same laptop I used to record these, which is Dora's laptop. And we know this has a measure of 11, well, let's call this one 11.5 because that looks shorter, by 14 inches. So how can we find this area? This is sort of a rectangle. We can pretend it's a regular rectangle. So how can we find the area of that? That's just length times width. Thank goodness we have a straightforward question here. So what is 11.5 times 14? Quick, smart girl. What is it? Quick, quick, quick.
I'm not good at calculating in my head.
Okay.
I need a calculator.
Well, we don't have calculators here. So 5 times 4 is 0. That's 2. So 4 times 1 plus 2 is 6. That's 4. We bring down a 0 before going to our tens place, and then 115 times 1 is just going to be 115. If we add these together, we get 0, 1, carry the 1, 6, 1. We have just one decimal place up here. Just one decimal place. We need one decimal place in our answer. So what is the area of our super sweet Dora laptop? It is 161 inches squared. Again with the clapping. Good it. Alright. Number 5. I started us off here so this one doesn't take all day.
Shadows.
And they always like to give you this problem of a guy in a shadow compared to a building in a shadow. And you can actually do this. This is kind of interesting. You can find the height of really tall things just by having a shadow and a tape measure handy. So this is sort of useful in real life. So it's the same time of day. A person who is 5 feet 2 inches. And we went ahead, we converted this. This is 2 out of 12 inches. So we can say he's 5 1/6 feet tall. So 5 1/6, that's our guy. Cast a shadow 3 foot 4 inches. So 4 inches is 4 out of 12 feet. So it's going to be 3 1/3 feet. That's a shadow. She's talking to the cat, and the cat bit her. That's so funny.
Oh, it's not.
Alright, so building cast a 12-foot long shadow. So what is this height of the building? Well, suddenly we have 3 numbers and an X. We're comparing a height and a shadow. That's 2 things we're comparing. This is a proportion problem. We are comparing height.
Oh no. You know, I got you some milk.
To shadow. She says she's really smart, but she has difficulty telling the difference between the milk jug and the water jug, which never ceases to stop being funny to me. So let's look. I know, I'm mean. Whatever. 5 1/6. Let's not do fractions and fractions. 1/6, if you divide that out, hopefully we're learning these. This is 1/6 minus, that's 4. This is about 0.16, so we can say this is about 5.16. That's his height. His shadow, 1/3. Oh, please tell me you know what 1/3 is. This is 3.33. That is his shadow. And the shadow of the building, we know that one as well. That's 12. And we're solving for X here. Now we could probably look at this and just do 5 over 3 and then round it and we'll probably be okay, but we've got a calculator. Let's use a calculator. So we cross multiply. I guess I can write this down first. Cross multiply 5.16 times 12. And that'll give us 61.92. And we can divide that by 3.33. And that gives us this kind of crazy number, but it repeats, and it's 18.59. 18.59. And we want to round that to the nearest foot, so we can say this is about a 19-foot tall building, which is actually kind of a short building, but what are you going to do? It's about 19 feet. So let's look. Let's say, what if we had simplified this? So what if we had not looked at that? Let's just do 5 times 12, which would be 60. If we divide that by 3, we'd get 20 feet. So it's a little bit different, but on a multiple choice test, you got to assume these answers aren't going to be like 19, 20, 21, 22. There's going to be more of a spread about it. So if you notice that your answer choices aren't close to each other, feel free to do a little bit of rounding. Use common sense. Don't do a bunch of extra decimal work just to try to get the most exact answer, because if you're smart enough, you can realize that if you round it, you'll be close. You just look for an answer that's close to what you got. Okay? Hopefully that made sense. Thank you for the milk. Alright. Go drink some milk. Pause the video. Get some milk, kids. It's good and good for you. Alright. Last one. Hopefully you're back and you had milk. This spinner has 3 green sections, 2 white sections, 2 brown sections, and 1 red section, officially making it the ugliest spinner ever. Whose idea was this? I spent like 5 minutes trying to make this not look stupid. I can't do it. I can't even write on it. That's how ugly it is. This is the ugliest spinner ever. I hope the person who designed this was fired, because look at that. That's gross. Okay? But whatever. What is the probability of spinning white on the first spin and red on the second spin? So we are trying to find probability of red. No, wait, not red. The probability of white and then red. So we've talked about these ones. We look for the probability of each event happening on its own. So what is the probability of spinning white? Well, there are 2 white sections, so there are 2 favorable outcomes. Out of how many total outcomes are there? There's 5, 7, 8. So the probability of spinning white is 2/8. And let's see if we can get that to happen. Let's try again. Be there. Yes. Okay, we got white. And then the second one, we want it to land on red. So what is the probability of getting red? There's only 1 red section, so that's 1 favorable outcome out of 8. And this might take a while to land on that, so I'm not really going to try this too hard. We'll give it one go. Go, 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 go. Oh, we did it. Oh, it's magical. This is the best day ever. Not really. Whatever. So, last thing we need to know is just that this "and" just means times. We're taking these 2 probabilities and we're timesing them together. We could simplify this, but let's not. Let's just multiply. So we go straight across. 2 times 1 is 2. 8 times 8 is 64. So now we have 2 64ths. We can simplify that. What is 2 64ths simplified to? Well, they're both even, so I know I can divide both of them by 2. 2 divided by 2 is 1. 64 divided by 2, or half of 64, is 32. So what is the probability of spinning white then red? It is 1 over 32. And we finished in less than 20 minutes. So, hooray. And I got 5 seconds to spare. 4, 3, 2.